Hello and welcome back to the Turks and Caicos Reef Fund's Stony Coral Tissue Loss Disease Observer Training Workshop. My name's Alizee, and in this episode we're going to be looking at the 14 most susceptible and most common susceptible species that are found in the Turks and Caicos Islands and likely in the region as well. How to identify them, different tips and pointers, and how they react and what they look like when they have stony coral tissue loss disease. So without further ado, let's get started. The susceptible species. So as I mentioned in the first class, there are over 20 susceptible species, but there are 14 main species here in the Turks and Caicos at least that are both very common and susceptible. And they're the first 14 that we would want any observer to learn. There are, of course, other species outside of this list that are susceptible. And if you are already familiar with local coral ID and you can include these other species in your survey, then of course we encourage you to do so. The more you get, the more specific and detailed information that can be included on your survey, the better. And also remember, I mentioned photographs in that first section. If you do see species outside of this list that are affected, or that appear sick and you can take photographs, please do and email them to us. Again, I will be putting up that email address on the screen, but I'll just remind everybody it's Alizee, ALIZEE @tcreef.org. And before we start, I just want to mention down here, we've got this note and it lets you know that the acronyms for corals are made by taking the first letter of the genus, such as Diploria here, which is always capitalized, and the first three letters of the species, Labyrinthiformis, which is never capitalized. And this gives us our acronym DLAB. I will admit, when I learned the corals, I learned acronyms first. I found them easier to learn than the full scientific name, and I found them less confusing, to be honest, in certain parts than the common names. But it's different for everybody. So on these slides, I will be including all three: the common name, the scientific name, and the acronym. Now, right now, I'm going to show you the 14 corals. I'm not going to go into details about identification methods. I just want you to have these 14 corals, the images already in your head, when we then go back and look at identifying features of each species. So bear with me, I'll just run through those 14 now. We have our maize coral, Meandrina meandrites, Mimea. Pillar coral, the iconic Dendrogyrus cylindrus, Desil. Boulder brain coral, Copophilia natans, CNAT. Grooved brain coral, Diploria labyrinthiformis, DLAB. Symmetrical brain coral, Pseudodiploria strigosa, Pister. The knobby brain coral, pretty easy to identify, I'd say. Pseudodiploria clivosa, P-cli. Elliptical star coral, Dichocenia stokesi, Disto. The smooth flower coral, Eusimilia fastigiata, EFAS. Great star coral, Montastrea cavernosa, MCAV. Mountainous star coral, Orbicella faviolata, OFAV. Lobed star coral, Orbicella annularis, OAN. This might give you an idea as to why I prefer the acronyms, because we've already seen 4 star corals now. We have our boulder star coral, Orbicella franksi, OFRA. Again, I will talk about this more afterwards, but I would like to mention that this coral image here is perfectly healthy. This is one of those odd corals that grows in a very irregular pattern and tends to have certain polyps that are already lacking zooxanthellae, even when the colony is healthy. So we'll talk about that after. We have lettuce coral, Agaricea agaricides. So that would be the AAGA, AGA. But again, I'll mention in a little bit when we go through the species that agaricias can be hard to identify. So whenever in doubt, you're going to use the genus, which is just agar. It's your first 4 letters of that first word that's capitalized, if you can't distinguish the species. And our massive starlet corals, Siderastrius siderea, S-Sid. We'll talk about those again in a little bit as well. Now, what about some of the corals that are not affected by SCTLD? Staghorn and elkhorn corals, our 2 acropora species, are thankfully not affected by SCTLD, although as we know they are both endangered species that went through their own disease outbreaks in the past few decades. And these are the predominant corals that different organizations around the region are growing in our nurseries. The other corals that are presumed at the moment unaffected are those of the genus Parades. So we have our mustard hill coral and our finger coral. Both of those are very common on the reefs, both shallow and deeper water, or on top of the reefs mostly. And thankfully they are not at the moment showing to be affected by SCTLD. Now last summer I did see some tissue loss on both of these species. However, that would have been from prolonged bleaching. As everybody here in the Turks and Caicos knows, if you work in the water, 2019 had a significant bleaching event, and the worst I've seen in my life here. So 20 plus years in the ocean here. And even though bleaching does not 100% spell the death of a coral, and wonderful news is that in Australia they were showing that corals can recover, some corals 5-6 months later, which is really positive. But of course, prolonged bleaching can lead to partial mortality on coral colonies and total mortality as well, and can lead to tissue loss. So we will see some images in the diagnostic differentiation section that will talk about how to identify whether it is just tissue loss from prolonged bleaching or whether you're actually looking at disease. So you'll get that in the next section. So stony coral tissue loss disease. Let's have a little look at this coral here. Here we have our top arrow is pointing to this thick brown tissue. This is healthy living tissue of a Monastrea cavernosa. And then we have our other sections here. We have this intersection, the bottom arrow down here, and then we have this margin here that's bright white. So the white edge is your disease margin. Now I'm just going to zoom in here, and you can really see that that is completely denuded. It's hollow, and you can see the lines of the septa. It's a very sharp image. And then in the central bit here, we have this yellowish green tint and a little thicker algae here, and that's turf algae. Turf algae starts to grow after 3 days of a coral being dead. So put in other words, the disease margin you're seeing, that bright white section, that section has been dead for a maximum of 3 days. After 3 days, turf algae starts to colonize the skeleton. So here, these are images from Florida, and you can see that a symmetrical brain coral, Pseudodeplorius strigosa, within less than a month, half of that colony has already been taken. So how quickly a colony dies varies, but in some cases, once a coral is infected, the disease spreads so quickly that the coral can die in as little as a few weeks. To be honest, I've seen corals here go within a few days, depending on their susceptibility, and then, you know, every species, every specific colony is different. Like in humans, some will succumb faster than others. However, we have seen the loss of some pretty iconic colonies here in the Turks and Caicos, one of which that I have photographs of is a very large MCAV, Monastrea cavernosa, great star coral, on the north side of the sand chute at the dive site driveway at West Caicos. So this photo that you're seeing here This was taken by Alex Brett on the aggressor, and it was taken on the 22nd of July, 2019. That's the back of the coral, looking perfectly healthy. And then on the front of the coral, you can see here that there's just one spot just up here that's got a lesion. Now, this is a really popular coral with the damselfish, often have their nests and their algal lawns right down here. It's a fairly recognizable colony as well, because it was about 8 foot tall, and I could not that I've ever tried, put my arms around it. The next time I was able to visit this site was on the 18th of September, so almost 2 months to a couple days later. And here's the front and back of it. So in 2 months, we've seen, I'd say, just over half of this colony has succumbed. Exactly 1 month and 4 days later, on the 22nd of October, 2019, the whole front is now gone and has quite a bit of turf algae growing on it. And we've got maybe 15% left on the back of this colony. This is a close-up I took that can really show you the sloughing of the tissue. So when we look at disease differentiation in episode 3 in section 3, we'll really talk about this more, but this is one of the signs of SCTLD, is you just see this tissue almost melting off of the coral and sloughing off here if I zoom in. And then you're left with this incredibly pristine denuded skeleton on the other side. And then on this side, the coral looks presumably perfectly healthy. And then this was on the 20th of January. So I wasn't able to go there for different reasons for a few months, but by the 26th of January, you can see that this coral colony has been gone for quite some time now. So this disease ravishing and the reefs, and the worst part about this is that observations show that once a coral is affected, like that MCAV I just showed you, the disease will kill the entire colony. There are generally no partial survivors. And that's the saddest and hardest part, is with many diseases, they will kill sections of colonies, but they will leave partial survivors. And those partial survivors are then able to go out and reproduce. Well, they don't go anywhere, they don't really move, but they can at least continue that genotype. With this disease, unfortunately, not only is one of the most widespread disease outbreaks on record, but it is also one of the most lethal. This shows you again a mountainous star coral that's got lesions coming up all around it. Now let's talk a little bit about coral disease in the ecosystem. In every ecosystem, there are levels, I should say, of endemic disease. Just like in humans, there are levels of endemic disease. And on the coral reefs, now this is based out of Florida. Unfortunately, we don't have that kind of baseline data yet here in the Turks and Caicos, which we're working on getting now for future. But in Florida, they say that they have an endemic disease prevalence of around 2 to 3%. And I would say we're probably similar here, if not less, right? With the fact that we have incredibly healthy and clear waters as well. What this means is that 2 or 3 of every 100 corals surveyed will have some ailment, some form of disease. And this is actually based on all coral species within that population. So I do want to make note that the 2 to 3% is based on every species within that reef. Now, if we change over here, we're looking at our current disease outbreak. Now, this is now species specific to the 20 plus susceptible species. But of those species that are susceptible, we are seeing 66 to 100% of the colonies on a reef getting this disease. That is absolutely huge. So for example, the Montastrea cavernosa, that MCAV, on that dive site driveway, we can now assume that 66 to 100% of the MCAVs will get this disease, if they have not already, within X amount of years. Remember, Florida is now on year 6 of dealing with this outbreak. And that is the reason why, very quickly before I move on, that is the reason why in our treatment and intervention attempts, what we're doing is not trying to save entire colonies or trying to stop the disease. Unfortunately, that's not something we can do so easily as it is waterborne. What we are concentrating on, what we are trying to do, is to preserve as much healthy reproductive tissue as possible to give the reef the best chance of recovery. That's what we're looking at here, is increasing our rate of recovery and our chances of recovery. All right, so I said we were going to look at those 14 corals a little more in depth, and that's what we're going to do now. We're going to have a quick look at the identification of stony corals, so a broader look at how do you determine whether this is a stony coral versus a fleshy coral or soft coral. Might seem pretty obvious, but we will look at a few little distinguishing factors, and then we'll go into those 14 specific species. So bear with us one moment. All right, so classification groups. The first thing is when you're down in the water and you're starting to just get the observer's eye. Before you start doing any surveys, we want you just down there kind of getting used to what you're looking for. So here are some of our classification groups. We have flowering cup, encrusting mold and boulder corals, mound and boulder corals, brain corals, branching and pillar corals, fleshy corals, plate, leaf, and sheet corals. Now, in Florida at first, they had just given these 3 classification groups. So not branching, just pillar, encrusting mound and boulder, and brain corals. However, I've also added flowering and cup because one of our species that's highly susceptible and common here, Eusimilia fastigiata, is a flowering cup and cup coral, falls into that classification group. And if we're honest, fleshy corals like that Mycetophilia, that cactus coral I showed you in our first session, they're very low on the susceptibility list, but they're not immune. And we also have plate, leaf, and sheet corals that are getting it. So, but what we're trying to concentrate on here is just getting to grips with those first 14. So what you're gonna look at is, okay, what is the polyp size? Is it a solitary coral or does it grow in colonies? So the coral on the left here is a scalemia, and it grows as a solitary polyp and can reach up to 6 inches. So those are very obvious when you see them, that's its own. I have thankfully not seen any of these showing signs of SCTLD, and as far as I'm aware, they are not presumed susceptible. Or we have our colony growers, and that's what we're looking for, is colony growers. Now these polyps, compared to 6 inches, these are about half an inch at the max, so under half an inch in length. And they then grow into these huge colonies that you can see here. Before we move on, this is one of my favorite photos. I took this when doing a survey on the 23rd of May, that first day that I first started really observing SCTLD off of West Caicos. And I went to go pick up my line, and there was this beautiful little scalemia right there. And then this little golden tail moray just came right out and scared the bejesus out of me. But just to give you a little reference to size, here he is next to the line that I was picking up. So these are little zip ties, and this here is 10 centimeters. So you can see that just a tiny little guy right there. Anyways, just a little distraction for a second. So again, another thing, depending on what species, and this will be as you learn more and more about coral identification and reef ecology, these may come in more handy. Point number 3, again, this is from the University of Florida, talks about the calyces of the corallites, the rims of the corallites or cups. Do they protrude or are they flush with the colony? Reason for this is most of the corals in the genus Parades are flush. They have innies versus outies. So these are, again, little things that you can look at depending on which species you're trying to identify. Ridges are incredibly important for brain corals, and I will be spending a little bit of time in the next few minutes looking at the ridges of brain corals and how that will help us, because we have 4 brain corals on out of the 14 species that we're going to be looking at, and we need to be able to separate and identify them. So let's go straight into it. I'm going to keep the little video right up here unless it does seem like it is blocking something important. So our first coral on our susceptibility list is maize coral, Meandrina meandrates, Mimea. This is one of the most susceptible species, and it's incredibly abundant here in the Turks and Caicos. It's amongst the hardest hit. So one of you want to look at with this is that the septa are perpendicular to the grooves. So these lines here going along the ridge where my mouse is, these are the septa. They're very angled, they have deep grooves between them, and they're going perpendicular to the grooves. Meandering maize is a little reference you can remember, but it's a relatively easy species to identify once you see it. Some people do first see it as a brain coral because it has a meandroid morphology, but it is separate. And again, the very sharp septa and deep grooves are an easy way to recognize. I will mention that maize corals grow in crusting, in mounds, in pillars. They change shapes a lot. There's a lot of variety. And here's a maize coral with SCTLD. For every species, there will be a photo of that species being affected by disease. The pillar coral. Pillar corals are one of the most easily identifiable ones, probably because their polyps are out during the day and they have that kind of 70s shag carpet look. They are iconic corals, and they're also on the ESA, the Endangered Species Act, and with the threatened status. Unfortunately, they are also highly susceptible. Very easy to identify. They form numerous heavy cylindrical spires that grow upwards from an encrusting base. And sometimes they can actually encrust further out and just have little spires growing out. But eventually those spires would grow into these large colonies that we see here. They're very common and they're quite unmistakable. And there you go. Okay, so now we're about to enter the world of brain corals. Our first brain coral, the boulder brain coral, Copophilia natans, CNAT, again, highly susceptible. It is the largest of the brain corals, can grow up to 7 feet. I'm pretty sure I've seen some that are larger than 7 feet, but I can't prove that. Now, interesting identification features for the CNAT. They have, their ridges and troughs are much thicker than other brain coral species, and they're more spaced out. So that's the first thing, is you're going to see this ridge here. I think it almost looks a little like a caterpillar or a centipede. They're thicker and more spaced out. Secondly, there is a very distinct line that runs along the top of the ridge where the septa meet. Thirdly, they're more often than not bicolored, either 2 distinct colors, like you can see here on the top left photo with green and brown, or variations of the same color, but they are almost always bicolored. And here you can see about halfway down the septa, there's another line, and that's where the color switches. So Copophilia natans are quite distinguishable. Again, once you start seeing these underwater with this information in your mind, it becomes a lot easier to identify. And here you can see that it is succumbing to the disease. I will mention, and this will be mentioned several times again, you can tell how quickly the disease is going across a coral colony by how thick the disease margin line is. It's a very thin disease margin, then you know that the colony is fighting and that disease is moving slowly. But the thicker that disease margin, the faster the colony is succumbing to the disease. Okay, our second brain coral is Diploria labyrinthiformis, D-lab, or grooved brain coral. Now, very distinct to CNAT. This one's quite easy, I believe, because basically at the top of the ridges, it goes right back down. Grooved brain corals have a very deep groove on the top of their ridges, also known as labyrinths. They more often than not have hemispherical heads as well. Another way to describe it is it looks like someone's made a ball of wet clay and then drug their fingers through to create these smudge-like ridges. They're not very regular is what I'm saying. We have the symmetrical brain coral, our third brain coral species, Pseudodiploria strigosa, Peaster. Now, this one is often confused with the Copophilia natans. But again, once you really do start seeing the difference, they will become quite obvious. The first thing I want to point out is that even though it might resemble others at first glance, it's usually not bicolored. They're usually one color. And on every colony, as it goes down towards the base of the colony, the ridges start to go either horizontal or parallel, and they become, horizontal or vertical, and they become parallel or symmetrical. So the idea here is on top, you have your meandering design here, and then as the ridges make their way down to the base of the colony, the lines start to go straight. And that is the one way to be able to identify a Peaster. The other thing I will say is that the ridges are much thinner than on the CNAT, on the Copophilia natans. But again, if you just look at the bottom, you'll always see that around the base, the lines start to straighten out. The Pseudodiploria clivosa, knobby brain coral, or P-cli. Very easy to identify, usually has numerous irregular knobs, very common on the shallower reefs of the Turks and Caicos. So I've seen this more in Grand Turk than I have on necessarily Northwest Point or on the reefs of West Caicos. But again, very obvious with the brain coral pattern, and yet very irregular, knobby, can form a spreading base with different knobs kind of sticking out like on this top right photo. And there you go. Next on our list, we have the elliptical star coral, Dichocenia stokesi, D-sto. This is also a very highly susceptible species and amongst the hardest hit. They're not very large colonies. They're about 4 to 15 inches, and they tend to form nice balls or just domed bases. And I see them on most dive sites once I started looking for them, you know, a couple, 2 or 3. So they're not the most common of our species. And I've seen them on the top of the wall or in clusters in the sand when heading back towards the mooring pins. That's where I tend to see them. Now they're quite distinctive because they have oval protruding corallites that can protrude up to 1/4 inch above the base. So they're quite sharp and jagged. And those corallites usually can form a lot of different shapes. So they can be elliptical or circular and even occasionally Y-shaped. And you can see here how quickly this colony is succumbing to SCTLD. Now, Eusomelia fastigiata, EFAS, or smooth flower coral, some people say that it's often confused or mistaken with the elliptical star coral, with the D-sto. Yes, this also has oval corallites, but if you look, they actually go down onto stalks rather than onto a rounded base. So this looks more like a bouquet of flowers another good way to try and remember it. And they have widely spaced polyps on long stalks and are usually in the yellow-brown coloration. They are succumbing quite quickly, and I'm noticing them more and more here as other corals kind of disappear in the background. So here is an image. I think I took this photo just a few weeks ago in Grand Turk. And if I zoom in here, you can really see how clean that polyp is and how sharp the lines of the skeleton are. So this gives us an incredibly intact skeleton to look at, because most other ways that corals will die, then the skeletons will also get scratched. But with this disease in particular, it seems to just empty the polyps of their fleshy tissue. All right. We have next our star corals. Okay, here we go. The great star coral, Montostrea cavernosa, MCAV, also known as SpaghettiOs coral. They're on the intermediately susceptible list. Again, this is based on Florida. Here in the Turks and Caicos, we've been seeing them get hit pretty hard. But I think because they are incredibly abundant here, and a lot of the colonies seem to be fighting, so that disease margin again is thinner, perhaps that's one of the reasons as well that they're considered intermediately susceptible. It does have the largest of the polyps of the star corals, and again grows quite large, 2 to 8 feet. One of the easiest to identify. As far as the coloration, you can't count on that. It has numerous varieties. I've seen them yellow, bluey, green, purple, orange, lots of orangey, reddish, like terracotta colored ones around here as well. I've been noticing a lot of recruits, especially around Northwest Point, and they can be fluorescent orange. So if you're seeing these little polyps in the sand that are just really bright, those could be MCAV recruits. Mountainous star corals, Orbicella faviolata or OFAV. Now, they are also on the Endangered Species Act. They are threatened. They're intermediately susceptible. They're incredibly abundant here in the TCI. We have them both on top of the wall in the morphology that you see on this top right photo, mountainous with different peaks as it goes up. But then the deeper you go, the more they'll start to plate out. So these are a lot of the corals that we see growing along the walls around Northwest Point and West Caicos, as well as I believe in Grand Turk. I mostly focus on the dive sites that I can access out of Providenciales because that's where I'm based at the moment. And so they tend to play out because, again, they're trying to get as much sunlight as possible. So they're increasing their surface area by plating out. What you're looking for is mountainous growth, these bumps and vertical ribs, and they can grow very, very large. Apparently there's a colony off of Fort Lauderdale that's estimated at 314 years old, and it's 15 foot tall. So I've not seen any quite that big here, but we do have some very, very large ones. And you can see here the disease margin is moving very slowly. These guys really are fighting, but they are getting them. We have been seeing the Orbicellas affected here in the Turks and Caicos from the beginning. Actually in Florida, my understanding is that the Orbicellas didn't start to get affected for a little while actually. So again, it just shows you the differences with every area. Is it because we have higher coral density that this disease is able to progress quicker across a reef? There are a lot of questions. Our lobed star coral, Orbicella annularis, OAN, again, on the Endangered Species Act, abundant here in the Turks and Caicos, and they form clusters of long, thick columns with these lobed, rounded heads that you can see here. Now, I would like to make a point about this. If you were doing a survey, this entire colony on the left here, this is one colony. So if there were to be disease lesions on some of these lobes, then that entire colony would count as the diseased colony. But if there were only a couple lobes on a species like this, this is the kind of one that you would want to try and go out and treat so as to preserve its reproductive tissue. And here you can again see a really great example of how it just empties out the skeleton here, and it's just devoid of tissue. Orbicella franksii. So I did mention this earlier if you were paying attention, because it's got those little white spots on it already. This is the least common of the orbicellas, but we do have them if they're fairly common around the Turks and Caicos. They tend to be much smaller, 1/2 foot to 3 feet maximum, with 1/8 of an inch diameter corallites. So very small little polyps. And they're irregular shaped and uneven correlates. So they tend to be quite bumpy. I think of franksii as Frankenstein or Frankenstein's monster. They're not the most attractive of corals, if you will. And they often have sections that are already lacking zooxanthellae and appear white even when the coral is healthy. So if you were swimming over this and you needed to have a look to decide whether that was a lesion or just natural lack of zooxanthellae, well, you're looking for tissue. Remember, if you were to look in closely and this had disease, then you would see into the skeleton. It would be sharp and devoid of living tissue. Next on our list, we have the lettuce corals, the agaricias. So Agaricea agaricides is the most common of the lettuce corals, so that's aga. But I would like to re-emphasize that because there are many different morphological occurrences of Agaricea agaricides, and there are several other species that fall under the genus Agaricea, whenever in doubt, just put agar, A-G-A-R. If you do know your different Agaricea species, wonderful. But if not, please bear in mind, data is only as useful as it is trustworthy and accurate. So always err on the side of caution. If you're not sure of a species, then you can just put it as the genus code. They're usually tan to brownish, yellowish. Sometimes they can be dark brown or chocolate colored. Here I usually see them more in the yellow to brown. And there you can see a close-up. So all Agaricea species do have these wonderful ridges that you can see here with these tiny little polyps. And often you'll see these little specks are kind of fluorescent. They're either yellow or green or orange. And it becomes obvious that it's part of the genus Agaricea. So again, I would just put A-G-A-R for that. Here is a plate form. So all three of the photos I'm about to show you are actually Agaricea agaricides, but just different growth variations. So this is a plating form with the disease here. Here is one that forms in that kind of lettuce shaped. And then here we've just got a small little dome one. Again, this probably, that entire little colony would have gone within a day. And last but not least, we have our massive starlet coral, the Psitterastrius siderea. They are on the intermediately susceptible species. They're incredibly abundant here in the Turks and Caicos. And pardon me, they're incredibly abundant here in the Turks and Caicos. And they're quite easy to identify once you see them. They tend to be these big, rounded domes up to 6 feet, and they have these deep pitted corallites. Almost looks like somebody took a pencil with an eraser and jabbed it into a basketball and created these kind of deep pitted corallites. So these are our starlet corals. Now they also get a whole host of ailments. So when we look at disease differentiation in episode 3, in our 3rd section of this observer training, we will be talking about some of the different things that affect Psitterastrias and how to kind of separate the different ailments from those. Here you can see SCTLD working its way across a colony. Okay, so that brings us to the end of episode 2. In the next episode, we're going to be looking at Andy Bruckner's slides on diagnostic differentiation. and looking at how to best diagnose whether you are observing stony coral tissue loss disease in the field or whether perhaps it is something else. So make sure you join us for the next episode. Also, a quick reminder, in the description below, you'll be able to find links to the different slides so that you can download those for your own reference. See you soon.